Alright guys, here we go, 4 or 5 video, writing a function rule. So after this lesson, I'll be able to write equations that represent functions. Alright, here we go. Again, please make sure that you are listening as well as watching. Your volume needs to be on. Alright, here we go. Many real-world functional relationships can be represented by equations. We can use an equation to find the solution of a given real-world problem. So this section focuses on building equations given some words. You and your friend are walking to school. Your friend started earlier and has a 15-meter head start. If you both walk at the same rate, write an equation that gives the distance you have walked as a function of the distance your friend has walked. Alright, so that last part's telling me what I'm trying to do. Write an equation that gives you the distance you have walked as a function of the distance your friend has walked. So my distance depends on how far he walked. Alright, and how are they related? So if I wanted to relate those two things, my distance is 15 meters less than my friend's distance. Alright, because he's got a 15-meter head start. So I just need to define some variables. So I'm going to let m equal my distance, and I'm going to let f equal my friend's distance. So if I wanted to write a rule, well, I know that my distance is 15 meters less than my friend's. So my distance equals my friend's distance minus 15. All right? Pretty basic. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit, more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this relationship? Okay, the outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. So, what's changing? Well, the temperature is changing and the number of chirps is changing. Alright, so the temperature is 40 degrees more than 1/4 the number of chirps in 1 minute. So my variables are going to be the temperature and the number of chirps. Those are the things that are changing. The temperature depends on the number of chirps. So this will be my independent variable, my dependent variable. Here we go. So the rule would be the temperature equals 40 plus 1/4 n. N is the number of chirps. Okay, the temperature is 40 degrees more than 1/4 the number of chirps. 1/4, 1/4, n plus the 40. Okay, you can put plus 40 at the end instead of in the front, but the way I read it, 40 degrees more, so blame plus 40. Okay, landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? Function rule that represents the total amount of waste after m months. I could have just said, what is an equation that represents the total amount of waste after m months? All right, so the amount of waste depends on the number of months. The total waste is the original amount of waste plus 420 every single month, so 420 per month. My variables are going to be the w, the total amount of waste, and m, the number of months. So the function rule would be w equals 50,000 plus 420 m. 420 times the number of months, and it started at 50,000. Okay, so as long as you can break it down and then define your variables, I think it's pretty easy to write your equation or your function rule. Billy has $500 in his bank account. Each month he pays his little brother $5 to do his chores for him. Write a function rule that represents the amount of money Billy will have remaining in his bank account after m months. Alright, function rule represents the amount of money Billy will have remaining in his bank account after m months. So his remaining amount is the starting amount minus $5 each month. Alright, so A is the amount remaining and m is the number of months. You can pick any letters you want, any variables you want. I just picked A for amount and m for month. So I start with 500 and I lose 5 per month. So the amount remaining is 500 minus 5 times m. I'm losing, so my amount is going down. That's why it's minus 5 times the number of months. Cal charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost of n days of boarding plus a bath. N days of boarding plus a bath. So the number of days is a variable and the cost is a variable. The total cost equals $12 plus $15 per day. That $12 is the cost of the bath. So it's $12 plus $15 every single day. So my variables are going to be C is the cost and N is the number of days. So according to how it's related, the total cost C equals $12 plus 15 times the number of days. All right. So how much does it cost for a $10 stay at the kennel? Does a $5 stay cost half as much? Well, if I have my equation now, or my function, all I have to do is put in the 10 for the n, because n represents the number of days, and it said 10 days. So I just put the n in for the 10, and I'll figure this out. 15 times 10 is 150, plus 12 makes 162. All right, so $10, a 10-day stay is $162. All right, if I wanted to see a 5-day stay, well, I would just put 5 in for n. And if I calculate that, I would get 87. Well, is 87 half as much as 162? It's not. A $5 stay does not cost half as much as a $10 stay. Without the $10 bath fee, it would be half. But since the $10 bath fee is paid regardless of how long the dog stay is, the cost for $5 is not half that of the cost for 10 days. All right? Regardless of how long they're staying for that, they have to get that bath for $12 to start. Write a function rule for the area of the rectangle whose length is 5 foot more than its width. Remember, the area of a rectangle is the length times the width. So there's my picture. Area is length times width. Now remember, in the problem it said the length is 5 feet more than the width. The length is 5 feet more than the width. So instead of this L, we're going to put a W plus 5. The length is 5 more than the width. Width plus 5 would be the length. That way we only have one variable there. The less variables, the better. So there's the new picture, W and W plus 5. All right, so my rule, area equals length times width. And if I just plug in what I have, instead of a length, I'm going to put in W plus 5 times W. So the only thing I changed was that L there. And if I calculate that out, well, this times W would be W squared plus 5W. And now, the area of rectangle when its width is 9 feet, well, I have an equation or a function rule, and I can just take the 9 and I plug it in, and then I simplify. 9 squared would be 81. Plus 45, which would be 126. So the area is 126 square feet. Okay, so if I can build that function rule, it's pretty easy for me to just plug in an answer. All right, that's the end of section 4.5, my friends. I'll see you next time. Peace.